Okay, in this video we're going to cover section 12.2, which is limits and continuity of vector functions. And this is a very short section for us, so we'll only have this one brief video. So let f of t be equal to the vector function whose components are f1 of t, f2 of t, and f3 of t. Then the limit as t approaches t naught of the vector function f of t is equal to the vector whose components are the limit as t approaches t naught of f1 of t, comma, the limit as t approaches t naught of f2 of t, comma, the limit as t approaches t naught of f3 of t, given these limits of f1 of t, f2 of t, and f3 of t exists. At t naught. So in order to take a limit of this function, it's just a matter of being able to take a limit of its component functions. And if those limits exist, then this limit exists and is equal to that vector right there. So next, a vector function f of t is continuous at t naught if and only if each of its component functions is continuous at t naught. All right, so that's the extent of our official notes, and then we're just going to do a couple of exercises from this section. So we're on 12.2 page, which is page 764 in your textbook. So page 764, we are going to do number 4. So in exercises 1 through 10, compute the limit or explain why it does not exist. So for us, they give us the limit as t goes to 0 of the vector sine of t over t, comma, e to the t, comma, t plus the square root of 2. So this is our capital F of t, and they just wrote out the component functions for us there. So this is the limit as t goes to 0, of capital F of t, and now you just go back to your calculus 1 or calculus 2 to evaluate each one of these limits. If any one of these limits does not exist, then the limit of this entire thing doesn't exist. But all of these limits exist. So the limit of this vector is going to be equal to the vector whose first entry is the limit of this as t goes to 0. And you all remember from, I think you all learned that in calculus 2, if I'm not mistaken. I don't remember. But the limit as t goes to 0 of sine of t over t is 1. And as t goes to 0, e to the t is also going to go to 1. And as t goes to 0, this is just, you can plug in 0 there, and you're just going to get square root 2. I mean, you could plug it in there as well. And that's the extent of that. So the problems in this section are just a matter of you going back to your calculus 1 or calculus 2 skills and taking limits. You don't have to take the steps that you were forced to take in calculus 1 or calculus 2 and like go through and you want to use L'Hopital's rule or something. You don't have to do any of that stuff. I mean, you can do it on your own to figure it out, but you don't have to show any of that in this class, because that's not where our focus lies. So next we're going to number 6, which says the limit as t goes to 0 f of t, where f of t, so the limit as t goes to 0 of f of t, where f of t, they give us a piecewise function, a piecewise vector function. So it is equal to the vector t comma e to the negative 1 over t squared comma t squared for t not equal to 0. And then it is the vector 0, 1, 0 if t is equal to 0. So we want to take the limit, we want to take the limit as t goes to 0 of f of t. So now just remember that we're taking the limit as t approaches 0. So t is not going to be 0 at all. And we're just talking about limits, so you don't have to think about like continuity or other things that you may have, but we weren't asked for whether this is continuous or not. So you all would see like a piecewise function and be asked about continuity when you were in calculus 1. We're just flat out taking the limit. T is approaching 0. T never reaches 0. So we don't care about the second part of the function at all. All we care about is this part of the function up here. And the limit, and all of these limits, that limit and that limit and that limit, do those limits exist as t approaches 0? What are we going to get? So as t approaches 0, that will go to 0. And they all three have to exist before we can say that this limit actually exists. So if one of them doesn't exist, then this limit doesn't exist. As t goes to 0, what is going to happen here? So as t goes to 0, now remember this is the same as 1 over e to the 1 over t squared. And as t goes to 0, as that goes to 0, then this thing right here is going to go to infinity. Let me just rewrite it. So this right here is 1 over e to the 1 over t squared. As t goes to 0, this exponent right here is going to go to infinity. So that means this whole denominator is going to go to infinity, which means this whole term is going to go to 0. So this one exists and this one exists as t goes to 0. So we're going to get 0, 0, 0 for all three of those limits. So our answer there would just be 0, 0, 0. All right, and that's all we're doing in that section, is just briefly looking at limits of vector value functions. So that concludes 12.2, and in our next video we'll start section 12.3.